Okay, 3.3 is all about measures of position. We've done measures of centers and measures of variation. So what we are going to do is we are going to find the z-score for the data on those two test scores. So what we need to know is, did she really fail those test scores, or?
It's just that she had a 30, but we don't know if it's like a 30 out of 30 or.
Yeah, we don't know what was the max score even. So did I put that problem back up, or do I just need to go to the other slide? Okay, so this is it. So a student scores 65 on a calculus test that had a mean of 50 and a standard deviation of 10. 30 on the history test, 25, and a standard deviation of 5. So how that actually helps us is we can put it all together with what we call a z-score now. So we're going to take the value, so this is their actual score. Then we'll need to know the mean. So some of these problems, if you're asked to do all this stuff, you'll actually have to find your own mean. Okay, so for the first one, value minus mean. So z, for the 65 one, I have 65 minus 50 all over 10. So 65 minus 50.
Where did we put in?
Right here.
Oh.
It's kind of just in a weird place. 15 over 10 is 1.5. Okay, so that really doesn't mean much to us yet, right? That's just a number. That's so far. So we'll talk about what it means in a second. So let's find the z-score for the history test as well. So I have 30 minus 25 all over 5. Okay, and you're seeing where I'm coming up with all those numbers there. 30 minus 25 is 5 over 5 is just 1. Okay? Which one's better? She did better on the calculus test. Why?
Yeah, 1.5.
1.5. This compares things that totally don't even have the same ranges. Z-scores, when we talk about it, what would the average be? Like if I had to do the average, if I got 50 on there, what would my z-score be? So if I got a 50, but my mu is also 50, and my standard deviation is 10, I get a z-score of 0. Is that bad? If you did average, if my average score was 90 and you got an average score, would you be happy with that? Yeah, that would mean that you were that 90th person. So 0 is not a bad z-score, it just means it's the average z-score. Okay, so that's what's going to happen is 0 is the average. I don't know if I put this on a different slide or not. Let's see what I got on the next one. Okay, so for the next thing, so 0 is average, that's just kind of a nice thing that we'll talk about. So we found her z-scores already. More about z-scores. Okay, so if I have test scores are just kind of the easiest one to go with. So I made this slideshow last week, and now I can't remember everything that I put on it. So now I'm like, okay, where am I going next? Okay, just in general, z-scores are kind of between -3 and 3. As you can see, even if she'd gotten 100 on that test, what would that have really meant? Okay, there is no rule there. If you get anything above or below that, if you get -50 or +50, check with me because you're doing something wrong, and I definitely want to know what you're doing wrong. Okay, so just kind of use this as a guideline. I think I've seen, actually doing statistics problems, I think I might have seen a 6 one time doing these. It doesn't happen very much. So even if you're getting 10s, you need to check with me. Okay, 3 to 4 decimal points, no rule, so just kind of check with me for your computations. Okay, let's go back. I can't remember where I'm going with everything. Okay. So, test A and test B. So this is just different notations. Finding the z-score. So if you had a -3, it'd mean you did, as a z-score, you did pretty bad on that test. If you had a +3, cool, you probably were the top of your class right there, okay? So that's kind of what that means. -3 was you failed to even write your name on the test, and that kind of thing. Yeah, and the teacher hates you. Okay, so if this is X, so just these are the different notations. This is definitely meaning that it's a sample. because if it was the population things that we were trying to find, it would have been, we would have still had x, then we would have had mu instead of x bar, and sigma there. So they all mean the same thing. We're going to use them all in the same place. My value for test A, we're going to find stuff for test A. My value was 38. I subtract my mean from that, and then I divide that by my standard deviation. Okay, 38 minus 40 is negative 2 over 5, so negative 0.4. Okay, it's within our range, so we're happy there. Negative 0.4, they didn't quite do average, but they didn't do real great either. Not terrible. Okay, some of the next things we're going to talk about after we find this one, so we do 94.
So if they got a 0, it'd be like, oh, you did average.
Yes, yep. Okay, 94 minus 100, negative 6 over 10. 0.6, negative 0.6. Yep, pay attention to signs, like I'm trying to forget. Which one did she actually do better on, though? The negative 0.4. So we're talking about, like, highest value, so don't just think, oh, 0.6 is higher than 0.4, so make sure you keep your positive, negative signs, kind of that rule in the back of your mind. So even though she did a 38 on that test and a 94 on that one, she did better on the top one. Okay, so it's kind of like putting it into a percentage, but it's also taking into account whatever that center was. It's taking account into the center and the spread. Okay, percentiles are, oh, oops, one thing I just wanted to remind you from last week, talking more about z-scores, is, do you remember how many was within one standard deviation? No? So that was something like definitely have in your notes, and it was kind of a drawing, but it didn't really mean much last week. So our z-scores, so we just found negative 0.4 and negative 0.6. Okay, so our mean is always right in the middle. So if I draw, this is our graph, we'll do a lot with this later on. This is my mean, or x bar. Just they're the same things. Within one standard deviation, and Taryn, since you're in calculus too, I'm going to mention this. Like in calculus, when we find our second derivatives and set it equal to 0, we get what we call that point of inflection. That's where this is concave up, this is concave down. Okay, that's where that first standard deviation happens to happen at. So when you're drawing your graphs, which we will do a lot later, we're not doing them now. That's where those bars go, is where that change is in where it's going up. It's kind of going down. They're still decreasing, increasing. That's not it. Okay, so within one standard deviation, we call this usually like mu, or x minus mu. X bar. Nope, I'm going to write that wrong. Mu minus sigma. My mean minus my standard deviation. This one is addition. I can't write my right letters. Mu plus my standard deviation. Sometimes you see like a 1 in there. 68% of my data is within that. If you're in the middle 68, are you doing pretty good? You're doing about the same as everybody else. Okay? So that's where this score really represents. So negative 0.4 would probably be around here. So they're about right there on the graph. That's pretty close to the middle. Negative 0.6, not far off. Probably right there. So they did a little bit lower than average. Okay, not much lower. Not by any means. And then also remember, and you already have these in your notes, so you don't have to redraw my graph. This guy would have been mu minus 2 sigmas. So 2 standard deviations falls within 95%. And if I did 3 standard deviations, I can never remember if it's 99.7 or 99.8. I think, yeah, and you already have it in your notes from last week too. So within 3 standard deviations, so that's why I say that it needs to be within negative 3 and 3, because 99.7% is in there. You might be like the bottom 0.5%, or the bottom like 0.2%, or the top 0.2%, but that's not going to happen very much. Okay, so that's kind of we drew it last week, but then we just kind of were like, okay. I just kind of felt like it was in the wrong section in the book, but I didn't change it either, so. So percentiles, you probably gotten tests that like you're at the 97th percentile. It didn't say you're at the 97.5 percentile. Maybe you haven't got 97, that's really high too. Maybe like 60th percentile if you're doing good at something. So we don't have like points in our percentiles. We use P with a subscript. So the first percentile, that wouldn't be very good. That would mean you're better than 1% of the population for whatever it is. So if you had a data value of P3, you're above 3%. If you had, I don't think I've ever seen a P of 100. If you had a percentile of 100, you are the best. There is nobody better than you for whatever you're doing. Turn, yeah. Okay. P99, so that one can probably like actually happen. You see a lot like medical growth charts. So this is like baby growth charts that you see a lot. Weight, heights, years, okay. Age.
Well, yeah.
Yes, that's exactly what they are. This is where you're using them a lot. Okay, so you'll see charts like this. Okay, so if they're at the 50th percentile, well, we still need to know some other information about them in order to place them. Okay, so if you're saying percentile, I assume you're talking about everybody else is the same age, the same blah, blah, blah. Otherwise, there's not much comparison other than that percentile piece of it. Okay, so yeah, that's where we use percentiles a lot for. But actually, if you notice on this one, see like some of the things that it has is 25th. That's an important percentile. It doesn't have like a line for everyone. So it has 95th, 90th, 75th, 50th, 25th, 10th, 5th. So those are kind of like important numbers that we end up using a lot. So let's make one. I just marked on my shirt. Okay. Or actually, we're not making one of those. We're going to make a cumulative frequency. Does this seem like it's in the wrong place too? Is this from the last chapter? I feel like I just totally... Okay, oh no, we're just going to do it with percentiles instead of... Okay. Isn't that a wonderful sign? Okay. So, cumulative frequency percentiles are basically just whole percents. Cumulative frequencies, the only thing I have so far is 24. 24 and 62 is 80. Oh my gosh, I can't add today. 86 and 72. Is somebody going to add for me? 158. And another 26 is 184. And 12 is 196. And 200. Oh, look, it already had a 200 down there. So that didn't really help us because we still had to find the cumulative frequencies. So now we're doing the percents. 24 over 200. Are you dividing somebody? 0.12. Go out a couple percentages just in case we need to round. That was even though, right? Okay. So cool. We like things that go in evenly. 86 out of 200. 43. Is that even? Okay. 158 out of 200. 79. 184 out of 200. What? No. No, that can't happen. I can't have my percents. I have 12 and 43 plus 79 plus 90. They need to all add to 100% at the end.
100%?
Yeah. Because my last number will be 100 or 200. Oh, yeah, no, that makes sense. I forgot that I'm doing cumulative things. I was thinking that I was doing like 72 out of this. Okay. I'm happy again, sorry. 196 out of 200. 0.98 and 200 out of 200. Sorry, that was not what I was trying to do. And that one's actually 100% or 1.00. Okay, yep, I just got lost in my mind. Okay, cumulative frequencies. Remember, if we just did this, there's no, I don't think there's a reason to like write down a formula for percents because I think you guys usually know how to find percents pretty quickly. Okay, if you had to write it as a percent, make sure in your chart you're doing 12, 43 with the percent sign. I hate having to write a percent sign every time, so I skip it, but don't skip it. 100%, yeah. Okay, so then you're just going and plotting those on there. 89.5, so we're using our lower class boundaries, or how many is actually under 89.5? 0. So that's, we're going to have a 0 at that lower boundary. My next boundary, I'm going to have a 12%, so let's go find my 12%. My next one, 43. 79. You like my what? My graph dance? Sorry, is that terrible? Yeah, it's terrible. 64. I was trying to see what it looks like in the video too, and the next one is like 100. So what we kind of see is always like this S-shaped type of graph, and that's what we should see with most percentile graphs. If they're what we call normally distributed, we're not going to talk a whole lot about that. I just keep mentioning it. Blood pressure readings. So this was only for like systolic blood pressure. They should be, or they are. Yeah. Yeah. Okay. So that's how you would do those graphy dudes. Okay. We're going to find percentiles. Okay. Let me erase this. Okay. So I gave you new data. This is just highlighted for my 12. My book thingy was highlighted. That is so weird how it looks on this thingy.
Does it look ugly?
Yeah, I hope it doesn't look ugly like when it actually is like produced. You want me to start doing that? I'll record them afterwards.
Like be in a different podcast.
There's supposed to be like a live one that's coming up. So I don't know if it's like live and records or if it's just like a video conferencing thing that's done when it's done. Because that would be cool, because that way,
Yeah,
I don't know, if you
like
wanted
sitting
to.
at home, like
Yeah.
video conference.
Yeah, instead of having to wait a couple hours for it to upload.
Yeah.
I don't know how it'll work or not. We'll try it next time somebody's sick. So the number of values below X, we're going to add a half to it just so we actually take into account that we're counting that number. The number of values, and then we're going to times it by 100. That timesing by 100 is basically just throwing in that percent sign. You guys should be pretty good writing it as a decimal or a percent without having to, oh, don't forget, I forgot to put it in that formula. Okay, so that's kind of like the last step that I kind of ignore until the very end. Okay, a teacher gives a 20-put test to 10 students. The scores are shown here. Find the percentile rank of a score of 12. Is 12 like on here? So how many values are below? Oh, whoops, how about we put them in order first, because that will make everything better. Make sure you always put things in order. So I have 2, 3, 5, 6, 8, 10, 12, 15. 18, 20. Okay, so we're putting things in order. How many values are below the value that I'm talking about? This point, I'm talking about 12. So I have 1, 2, 3, 4, 5, 6. So we're going to say 6 plus a half over, how many total values do I have? 10. Okay, so it's kind of weird to add that half in there. And what it does is, because if I didn't add that half in there, I wouldn't take into account, like, the possibility, what if somebody had gotten another score, or, so we just, it's weird, because if not, then we're actually just finding the percentile for this number, okay? So 6.5 is 0.65, okay? And then to change it to a percent, we're doing times 100 is just 65 percentiles. You could, I don't know how exactly your book writes it. You could do like 65 is equal to, or it'd be like P65, sorry. P65 is equal to 12. I don't know what you said. I don't want to know what you said either. Okay.
Karen has some problems. Everywhere.
She was drooling on herself earlier too, so. Okay, so you got that one down? Ish, kind of, whatever's on Pinterest might be better, or Twitter, or. Okay. Order the data, we've done all that. Oh look, I had everything nicely on there. I should have just kept clicking. More percentiles with the same data. What is the percentile rank for 6? Let's see if I put any more stuff on there. No, I didn't. Okay, so the percentile rank for 6. How many data values are below 6? 3, then I add a half, and I divide by how many points I have, which is 10. So 3.5 over 10 is 0.35, which is the 35th percentile, is equal to 6. Okay, it's just kind of that change of notation there. I'll write out like 35%.
So is it always that?
What, always?
Oh, just for this, sorry.
Yeah, I mean, we're always adding that half in there. If you were working with like decimal places, though, it would be weird again because then we would add.
Why are we always adding?
To make sure that we actually count. What if I actually had a data value of like 5.5 in here? And maybe that one wasn't there. Okay, that would make sure that we accounted for that one. It's kind of weird because we're not working with them. But we still need to think about the fact that if we did work with them, I don't know. It's weird. I know this isn't it. Come on, there you go. Okay, first thing, oh, what is it doing? Which one am I trying to get to? Okay. Okay, so we'll just write all this stuff down. Okay, now we're going to try to find what is the 10th percentile. Okay, so first thing we always need to do is arrange in order. We're still using this kind of formula that C is representing whatever, like the count of whatever number. I'm trying to figure out a word thing for C, and I could not find it in the book at all that it meant to say for C. I really couldn't. Yeah, it just C is a whole number. It's just some kind of number that it gives you. Okay, N is still the number of values. P is the percentile you want to find. So these are kind of the rules that it says if C is not a whole number, round to the next whole number, then count. If it is a whole number, you would think, oh, we just get to pick that number, but they don't. No, of course not. There's no like easy thing. You always have to do something else for it. If it's a whole number, we're going to use the value between the next ones. Okay, so we'll basically find the mean of the next two numbers. It's weird. Okay, so let's find the 10th percentile in here. So C is kind of like how many places we'll count to after we find that number. So C is equal to, we have 10 values times, we want the 10th percentile over 100. Okay, so I'm finding I have 100 over 100 is just 1. C is a whole number, so that means we actually have to pick out that. Did I really mean to write 10th? Because I just don't remember doing that one at all.
Can we stop?
No, we can't stop.
This is just getting ridiculous.
Huh. Yeah, I just made up this problem, and I shouldn't make up problems for you. Okay, so anyway, this is an example of when C is a whole number. Okay, so where is C, where is my first term? So that's what I'm finding. My first term is 2. Hey, wait, watch. Guys, watch. Okay, I have my first term. I have to find then the average of these two terms. Okay, C is a whole number, so I have to do 2 plus 3 divided by 2. I'm always going to be dividing it by 2. Okay, 2 plus 3 is 5 over 2 is 2.5. So that means my 10th percentile, so my P10 is 2.5. Yep. I just kind of do a little bit. Okay, so that's kind of the weird thing. I think that's the weirdest thing. I'm not, yeah. I can. Yeah, that's the weirdest thing, is that when C is a whole number. Okay.
But C usually isn't a whole number?
The couple ones that I've done, they've come out to decimals, which actually is a little bit nicer. So when they're decimals, we just like round up and we're happy. Maybe, maybe. Come on, just do it. Okay, let me click like that. Okay, that works. Okay, if C is not a whole number, what we're doing is we keep the same data in there. So we're going to find the 25th percentile. So we have C equals N, we still have 10 points, times 25 over 100, and that gives us 2.5. Now what we're going to do, so that kind of seems weird because 2.5 was the answer we got for our actual 10th decimal place. Totally ignore that. We don't care about anything else about the other ones. Okay? The 25th percentile, then, we need to go up to the third number. What is my third number? 5. So then I'm going to say, hey, my 25th percentile is 5. It is weird.
So wait, the 3 means the third number in the thing?
Yep.
Okay.
So this is my 1, 2, 3. It is weird because there's a 3 in the data, right? And we just want to say, oh, hey, it's 3, but it's not. Don't think like that. Okay? Yep. How did I get a 5? Okay, so I got...
Third number in the thing.
So you rounded that up.
Always round up, and then we're just picking that number. Okay, let's do another one. They're the whole numbers, because I don't know, I just think those are the weirder ones. Math. I just want to do I picture the alien history guy. Aliens. Okay. Okay, the 60th percentile, same thing. Okay, something else if you don't want to use this formula, kind of the other way to think about it that I think is more intuitive, is the 60th percentile. Yeah, that was a nice word, wasn't it? Okay, N times your percent as a decimal. So I can have 10 times 0.6. That gives me 6 still. Or I can do 10 times 60 divided by 60, or divided by 100. Okay, it gives you the same thing. So it gives us 6. Okay, every time we get a whole number, we have to count, we have to pick the 6th and 7th number. Okay, so the number that I have to use 6 and 7 basically divided by 2. This is not 6 plus. Do not think this is a plus. So I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to average those two numbers. And I'm always going up with that piece of it as well. Okay, so you're not always going down. So I have 10 plus 12 over 2 is what? 11. 11 is my 60th percentile, so P60 equals 11. And so if I were to put 11 back here on my number line, not that it's part of my data, but I would say, okay, what percentage is less than 11? 1, 2, 3, 4, 5, 6 out of 10. 60% is less than that. Because otherwise, we get it, okay, well, is that part of it, or is it what? What's going on? All right, I'm sorry. We still have, one more type of thing to do. And it is finding your interquartile ranges. So, I know, that's why I'm not going to give you, we don't have lots of time, so you're probably not going to have lots. Okay. Quartiles. Quartiles. First thing we always have to do, write this down real fast. Write in order. Find the median. We found the median. The median is called Q2. Also sometimes called the second quartile. Median, second quartile. Quartile, think 4 in a quart. I don't know, 4 quarts in a gallon. Quartile just means 4, so there's 4 in a group. The median of those values is called Q1. So we'll like separate those guys up. So this is where my median is. So that's my Q2. Then I'll take that path and I'll do it again. And I'll find that median. That one is sometimes called Q1, sometimes called first quartile. You'll see lots of the same meanings with different words, basically, or different notations. First quartile, you might see them with numbers. You might see them with everything spelled out. The median of the values above those, so if I'm looking at the top half, so you can kind of see it. No, I mean, if it helps you, you can, but... find the median of those values. Of the top half is Q3. Okay. We will find later on the interquartile range. We will like in a couple seconds later on, that's what I mean. The interquartile range is Q3 minus Q1 is equal to your IQR. So those are all numbers though, okay? So there's lots of letters to represent numbers. So now let's actually find things with those numbers. I know. I know. I make you do a lot of things. Okay. So find Q1, Q2, Q3 for the data set.
We only had 3 questions on homework. You want to know why? We covered about 80 different subjects.
Okay. Q1. So first thing, always put everything in order. So I have 5. Also keep things evenly spaced so you can kind of like eyeball your quartiles. That makes it a little bit easier too. 6, 12,
15,
13,
12, 13, 15, 18, 22, 50.
22, and 50. I did not keep it evenly spaced.
Outlier.
Yes, and we're going to talk about that in a couple seconds too. Yeah, it is. Look at you. Okay, so we need to find our median. So I have, so medians, remember, like we can kind of like, okay, how many terms do we have? We can do it the hard way. Once things are in order, we can just kind of count out. 1, 2, 3, 4. 15 is our Q2. Okay. Now, what we need to do is now we need to find, so this is also called our median, remember?
Oh, is this when we make this little box thing?
Yeah, that's how we make box plots. I wasn't going to make you make a box plot, but that's how you make box plots. Unless you really want to.
Is that where you have like the line and the box?
I'll make one for you so you can see it, but that way you know where your numbers are coming from again. Okay? So now it's really nice. So this one had a nice median that I just had to pick. Remember, sometimes my medians don't do that, and sometimes I have to average in the middles. Yeah, and when those ones suck. Okay, what these ones are, what are you looking at, Taryn? What's your question? Because it's the middle number? No.
There's
No, it's
4 on
not.
one side and 3 on the other.
Okay, that's because I didn't keep things evenly spaced, did I? Okay, 15 is not my Q2. Okay, evenly spaced things. So now I go here, and so I do, these are the ones that we were saying these suck. Over 2, so that's 14. If they're nice, yeah, you can do that. Is my Q2, so kind of mark it Q2. If I was writing it in percentiles, I could be like P50. Okay, those are equivalent to each other. Okay, now what I have to do is I'm splitting it down the middle, and I'm finding the median of the first parts. So count to the middle, 6 and 12. 6 plus 12 over 2 is 9. Okay, that is my Q1. My Q3 then, 15, 18, 22. 18 and 22, what's halfway between 18 and 22? 20 is my Q3. Okay, I'll make a box plot for you real fast. We're not, but what's my low point? My low is 5. My Q1, so really everything should be on a nice number line. So let's say like 0, 5, 10, 15, 20, 25. I'll mark some of them. 50. Okay. Okay. My first quartile then was 9. So sometimes you see box plots, you see them a lot on tests. So that's going to be like, let's make it a little less curvy. My Q2 was 14, so we also put a line there. And Q3 was 20. I needed a line there too, didn't I? And my last thingy was 50. We make a box around the IQR, which now, how did I find my IQR? What was my method for doing that, the last thing that I said? Okay, Q3 minus Q1 was 20 minus 9. My interquartile range is then 11. So if it asks you for your IQR, you could just say 11. There's no like notation-y things for it, I don't think. Okay, IQR is 11. It means, yep, enter between my nice quartiles. Okay, so this is Q1, Q2, Q3. This is my low. This is my high. QT. Okay. So my low and my high there, those are kind of nice. So that's what the graph would look like graphically. No, don't think so. I might be lying to you. Okay. Deciles, I'm not going to talk much about those guys because because we're almost out of time, and they're pretty simple. And
wait, don't erase anything.
Okay.
Well, just don't erase what you, because you're standing right in front of it. Okay.
Yep. D1 means my 10th percentile. D2 means my 20th percentile. D3 means my 30th percentile. Okay? Yeah. Yeah, pretty much. Not crazy. Outliers are the weird piece, so we're going to use this data. So actually, I don't even want to get rid of that.
50.
How to find 50 looks totally out of place on this data, so you can usually pretty well tell if you're going to, but mathematically, we need like a certain way to do it. So what was my IQR?
Do we have to do it?
Yeah, you have. Yeah.
For homework?
Yeah.
Well,
Okay.
you don't look like
Is 11. So then what we're going to do is whatever your IQR is times 1.5. Yeah, I know. Okay, so 16.5 is just a number right now. So what we're going to do is multiply. So I'm going to try to erase this stuff. So everything always in order. Q1, Q3, we've already found that. We've already found our IQR. We're going to multiply those numbers by 1.5. So Q1 was what? So
Q1 was
9. From our Q1, we're going to subtract our 16.5. Negative 7.5. Did we have any data points under negative 7.5? No, so we don't have any low outliers. We're going to do the same thing, only we want to make sure on this side. Okay?
50.
So, yeah, 50 is definitely going to be. So we're going to do Q3 plus 16.5. How about I actually write my number down? What was my Q3 number? 20? 36.5. Yes, I had one of that. So 50 was over that. So 36.5 is right there. 50 is an outlier. Most of the time, sometimes you can. Yeah, this one you can just look at it and probably say 50. There's also an easy example. Sometimes when you just have like a whole bunch of data, you're just like, I have absolutely no idea. Okay, that's why. Sometimes you're just looking at a lot of data. Yep. Okay. Formula-ish ways, if you like that, you could do like, I don't know, do you like that? No? Okay. Okay, we've already done the outliers. We already found them. I think that's it. Okay. Thank God.